Hi, I'm Mr. Schmidt. It is April 5th, 2011, and I am going to model thinking aloud strategy using a laboratory investigation description. This investigation is called the lab friction investigation. I'm going to read first, and then I'm going to think aloud. When you kick a soccer ball along the ground, you know that when you stop kicking the ball, it will eventually roll to a stop. What happens to the kinetic energy of the ball as it slows down? The law of conservation of energy states that energy cannot be created or destroyed. Therefore, the kinetic energy of the soccer ball does not just disappear. It changes form. Where does all that energy go? This is a laboratory investigation and an eFolio project. Get out your cameras and smile. Essential question: how does energy transform when an object slides or rolls? Or, why does something stop on its own? Investigative question: how does the rolling surface affect the energy transformation of a rolling car? Procedure starter: at a chosen height, determine the gravitational potential energy of a matchbox car. Think of a way to show how the energy transforms, possibly using different surfaces to make it obvious. Share your results with others on the eFolio. Connect back to the essential question. Hypothesis, variables, control, procedure. I suggest making a ramp. Don't forget that you know how to calculate the downward force of the car. Here's a hint: think weight. Also, you know how to calculate work. See if you and your group can put these concepts together to figure out the GPE of the car at the top of the ramp. When you know how much energy the car started with, you might be able to devise a way to know how much energy your car lost by the time it stops. In your eFolio, you can think about where the energy goes. The next picture is a data table. It has object type, surface, ramp height, initial GPE, and other potential data that we can put there. Analysis. Really smart conclusions will answer these questions. How does your data confirm or refute your hypothesis? What does your answer tell you about energy transformation? Conclusion. I'm looking for thoughtful responses to the following questions. How do your error sources impact your investigation? How do you know? What questions are left unanswered for you? What is a next step for this investigation? Helpful hints. How does the energy transform from gravitational potential energy to other forms of energy during the motion? Make sure to consider transformations into kinetic energy and other forms like sound, heat, elastic potential energy, and others that you might think of. For full credit and maximum college and career readiness, document this project on your eFolio. Thank you for listening as I read. At this point, I'm going to think aloud. Mr. Schmidt has given me some sort of introduction at the top of the page. Obviously, it must shed some light on what we're going to be doing in this investigation. When I kick a soccer ball, of course I know it stops. I've learned in class that there's a law called the law of conservation of energy that says that energy can't be created nor destroyed. He's trying to tell me that technically the ball should never stop unless there's some way that the energy changes forms. So that must be what this experiment's about. How does energy change forms, and where's that energy going? Let me look to see if my assumption is true. I'm going to look down. He says that it's a laboratory investigation and eFolio project. There's an essential question. Actually, there are two. And so I think Mr. Schmidt might say that these two questions are connected. Let me look at them more closely. Does energy transform? How does energy transform as an object slides or rolls? Or, why does something stop on its own? The only way that something would stop on its own is if it's energy transformed. So I'm guessing Mr. Schmidt wouldn't care which question I chose. Answers would probably be the same. We'll see. Investigative question says, how does a rolling surface affect energy transformation of a rolling car? I'm thinking that this question must have something to do specifically with the experiment. It has something to do with a car and energy in the surface. Car and the surface. And the only way I'm going to know what that's about is if I pay close attention, because obviously Mr. Schmidt's going to demonstrate something to go with this lab. Usually that's the way it is. So we'll see. Procedure starter. He says something about a height and a matchbox car. I know that matchbox cars don't roll the same on different surfaces. From my experience, I remember matchbox cars were trying to roll them on carpet when I was a little kid, and it didn't work. So I'm thinking matchbox cars on the floor might be different. I mean, I remember that because when I rolled them in the kitchen, they'd roll forever. So maybe I'm going to be changing the surface. in this experiment and seeing how far they roll. Because he does talk about rolling surface and energy transformation. And I know if the object keeps its energy, it's going to roll farther. So that must be what it's about. We'll see. Different surfaces. Yes, it says energy transforms possibly using different surfaces. Okay, I can think of a hypothesis right away. Obviously, I'm going to affect the surface and see how far the object rolls. And that also has something to do with the variables. So I'm thinking of variables. I remember for all of these experiments, there's an independent variable, a dependent variable, and constants. And the only thing I can think of is that, let me see, dependent and independent variables. I often get them mixed up. The dependent is the thing I measure, and the independent is the one that I'm changing on purpose. Well, I'm going to be measuring the distance the car travels, so that must be my dependent variable. And then the surface type must be the independent variable. So I've got variables, and I'm sure there's going to be some constants, things like how high I start the car, or the type of car I use. If I choose different cars, they don't roll the same. I remember when I was a little kid and the little spokes would bend inside my Matchbox car, and that one wouldn't roll no matter what surface it was on. Procedure. He says make a ramp in the first sentence. Obviously that's what I should do. When we get to class and see the example, then maybe I'll understand what's going on. He talks about calculating the downward force on the car. I remember that could be weight. Force equals mass times acceleration. That would be the weight. And I know that the object, if it's going to be on a ramp, it's going to be at a certain height. So I'm thinking weight times height is going to be the amount of work that the energy that's stored inside the vehicle. And hopefully that'll make sense. And as I look at the data table, I've got an initial GPE. So that must mean that I calculate how much energy is stored in the car at the top of the ramp. When it comes to the experiment, the analysis and the conclusion are going to come later after I actually conclude the experiment. So I'm not even going to think about that now, but I'll discuss it with my group when our experiment's done. I think I'm able to design an experiment procedure based on my variables. So now I'm ready to go. Thanks.